Welcome to Ask and Learn.
So again, we have to balance the redox chemical reaction in this question. So what we do is we again start with dividing the full chemical redox reaction into two halves. So what we do is we start by arsenic in this question, As4O6, which goes to As4, sorry, ASO43 negative. So first we have to balance the arsenic atoms. So we put a 4 here, and now to balance the oxygen atoms, we have 4, 4, 16, and we have 6 oxygen atoms here. So we have to add 10 water molecules here. And now to balance the hydrogen atoms, we have 20 hydrogen atoms on the left hand side. So we have to add 20 H positive here. And now if we see, we have 20 minus 12, so we have 8 positive charge here, so we have to add 8 electrons on the right hand side to balance the charge. So what is this? This is our overall oxidation reaction. Okay, now we start with the manganese one. So MnO4 negative goes to Mn2 positive. Okay, so we have to balance the oxygen atoms. So what we do is we add 4 water molecules on the right hand side, and we add 8 H positive on the left hand side to balance the oxygen atoms at first and hydrogen atoms later. And now we have to balance the charge. So if we see, we have 7 positive charge on the left hand side and 2 positive charge on the right hand side. So we will add 7. 7 minus 2 is 5, so we will add 5 electrons on the left hand side, and this is our redox reaction. Now we have to calculate the total reaction, or we have to add the two reaction. In that way, we have to balance the electrons first. So we will multiply this equation by 5, and we will multiply this equation by 8, so to balance the number of electrons. So 40 40 electrons, this gets cancelled. So what are we going to be left with? 5 As4O6 plus 8MnO4 negative. And if you look at the water molecules, we have 40 water molecules here. No, sorry, 32 water molecules here, and we have 5 into 10, 50 water molecules here. So 50 minus 32 is 18. So 18 water molecules here. And then we have on the right hand side, we have 20 ASO43 negative, and we have 8 Mn2 positive, and then we have H positive ions, which is 64 on this side, and we have 100 H positive on this side. So 100 minus 64 is 36. So 36 H positive on the right hand side. So this is our overall balanced equation. And now we have to see which is the oxidizing agent and which is the reducing agent. So if you see, the AS4O6, the arsenic goes from oxidation state +3 to +5, which means the oxidation state is increasing, and that's why it's the reducing agent, because it's oxidizing itself. It's oxidized itself and reducing others, whereas MnO4 2 negative goes from +6 to +2, and therefore it's decreasing. So this is our oxidizing agent, because it's oxidizing other and itself getting reduced. So this is our part A, and now we go to part B. So we go to part B, and part B starts, we will start the equation with P4S goes to HPO3 2 negative. So what are we going to do? At first we will balance the phosphor atoms by putting 4 here, and now we will balance the oxygen atoms. So on right hand side we have 12 oxygen atoms, and therefore we will put 12 water molecules on the left hand side, and we have 24 hydrogen atoms on the left hand side and 4 hydrogen atoms on the right hand side. So we will have to add 20 protons here. And now we have to balance the electrons. So on left hand side we have 0 charge, and on right hand side we have 20 minus 8, so 12 positive charge, and we have to put 12 electrons here. and therefore this is the oxidation reaction. And for the second equation, we have P4 goes to pH3. So first we balance the phosphorus atom, which is 4. Okay, and now we have to balance the hydrogen since there are no oxygen. So we will add 12 H positive here, and to balance the charge we'll have to add 12 electrons here. Okay, so overall our electrons are balanced, so we don't have to multiply the equations with anything, and this is our reduction reaction. Okay, since we are ending up gaining electrons in the course of reaction, so we will get this cancelled, and we will have 2p4 plus we will have 12 water molecules and 4HPO3 2 negative plus 4pH3 plus we will have 20H positive here, 12H positive here, so 20 minus 12 is 8, so 8H positive. Okay, and now we can simplify the equation. So we divide the whole equation by 2. So it will come out to be P4 plus 6H2O, giving us 2HPO3 negative and 2PH3 and 4H positive. Okay, and now we have to decide which one is the oxidizing agent and which one is the reducing agent. So P4 here is getting oxidized as well as reduced, so P4 is the oxidizing agent as well as the reducing agent. So this is part B, and now we go to part C. So in part C, again we started with the same phenomenon, that is taking the one half the one redox reaction into two halves. So we will start with MnO4 negative goes to MnO2. Okay, so we will start by balancing the oxygen atoms. So we will have to add 2 water molecules here for that, and we have to add 4H positive here to balance the hydrogen atoms. Okay, and now we have to balance the charge. So we have 0 charge on the right hand side and we have 3 plus charge on the left hand side, so we will add 3 electrons here. So this will come out to be our reduction reaction. Okay, and for the next reaction we have Cn negative going to CnO negative. Okay, so we balance the oxygen charge, oxygen first, so we will have to add 1 water molecule here and 2H positive here, and we have to balance the number of electrons. So this has -1 and this one has +1, so we will have to add 2 electrons this side to get the overall thing balanced. Okay, so this is our oxidation reaction, and now to get the electrons balanced or cancelled out, we have to multiply the first equation by 2 and the second equation by 3. So this gets cancelled out, and the overall reaction is 2MnO4 negative plus 3Cn negative plus, so we have 4 to 8H positive here and 6H positive here, so 8 minus 6 is 2H positive. Okay, and then we have 3CnO negative plus 2MnO2, and we have 4H2O here and 3H2O here, so 4 minus 3 is 1, so 1H2 here, H2O here. Now this reaction occurs in the basic medium, so we have to add the hydroxide as well to balance the H positive. So 2OH negative here and 2OH negative here. Now this overall will become 2 water molecules, and this is 1 water molecule, so this will go on the left hand side, so 2 minus 1 is 1. So the overall reaction becomes 2MnO4 negative plus 3Cn negative plus water gives 3CnO negative plus 2MnO2 plus 2OH negative. Okay, now MnO4, if you see, it goes from +7 to +4 oxidation state in the overall reaction, so it decreases, which means this is our oxidizing agent. Okay, because it's oxidizing other and itself getting reduced, whereas Cn negative, the oxidation state of carbon goes from -1 to +1. So, or sorry, the oxidation state of Cn goes from -1 to +1, and therefore it increases, and therefore this is our reducing agent. That means it's reducing others and getting itself oxidized.